Can you advise Amber Rudd on encryption at all?
Yeah.
Because she's got some shitty advisors. Are we streaming now? Cool, when's that turned on? Cool, are we good? Welcome to our people online, the joys of the internet. We can now stream these things around the globe, so no pressure to our next two speakers. So for those who've just joined, we have Harry from ECS and we have Stuart from Zero Day Lab who are going to do some talks for you. So without further ado, over to Harry.
Oh, how's that? Yep, we're good. Excellent. Okay, Stu, thank you very much for having me, and thank you guys for making the time on a Thursday evening. It's not quite Friday night yet, but we're getting there. Yep, that's me. Right, so first of all, a little disclaimer. When Stu asked for speakers and I offered, I kind of forgot my CISP exam was the same day. So if you've seen this before, or if I seem a little bit tired, you'll know why. It's been a long day, but I'm going to do my best. A few of you may be seen this before, for which I apologize, but hopefully for most of you, it'll be something a little bit new, and hopefully you'll learn a few things. So first and foremost, this is who I am. All the various logos, company, titles, etc. We can chat later if you want to know more. Don't think that's going to be what we're chatting about. So first and foremost, who here knows what a seam is? Who's heard of it? Hands? Okay. Who may have used one? So hands-on, user interface, or if it's command line, poor you. Okay, a little bit more. Yeah, if it's command line, wow. Okay, so I don't like reading from slides. I'm going to use this as a guide because I refer back to me being tired. But pretty much this is how the industry defines a seam. It's about analytics, and it's about analytics at scale for the purpose of security. And hopefully you all know what that means, meaning we're there to ultimately detect and hopefully enable responders to understand threats. People either trying to or who have succeeded in attacking and compromising your organization. Now, I work with particular technologies. I may mention them a little bit, but hopefully most of these lessons and most of what you're going to see are agnostic. So whether you're an open source house, whether it's Elk and Elasticsearch, whether it's based on Hadoop, or whether, which is my general experience, which is around Splunk, which is commercial software. But all of these lessons, I hope, are pretty generic. This is about understanding the value of using a tool of this type, why frameworks are really important, why it's not just a rule engine, and ultimately some lessons to learn from actually implementing and running with that type of solution. So moving from that, these are some of the kind of the typical use cases, or as I said earlier with a colleague, misused cases, or at least to detect them, of a seam. So you're looking for a number of things. So you may be more traditional, and you're just looking for something like number of failed login attempts in an hour. You may be getting to a little bit more advanced, and you're looking towards behavior. You're trying to baseline. You might be trying to do some peer grouping. You might be using it for more security fraud type things, so less about cyber and looking about things like e-commerce payments, about where people are logging in from. But all of it has kind of been on this life cycle now, and this is by no means a standard. You're not going to find this anywhere. This is my personal understanding of where we've come from and where we are now. Happy to take pointers if you've had a different experience or think there should be some movement here. Happy to converse. But this is where I kind of, the four main phases I see it going to. And you'll notice the third phase, threat intelligence, is crossed out. I know it's a buzzword. Intelligence is what people create. Computers produce data. Slight caveat to that of some of the more deep learning neural network stuff that we're maybe getting to. But if you're getting a list of IP addresses that are transit nodes, it's not intelligence-based, it's data. And you're trying to correlate that and do other things with it, but it's data, not intelligence. And next gen, another term that we use far too much and should never be used, because when it becomes current gen, it kind of becomes a problem. I'm looking forward to future gen, personally, and then we're going to have quantum gen and all kinds of gens, and it's a bit redundant. Ultimately, though, what people start talking about next gen typically is around machine learning, so applying algorithms to data sets to try and do some form of prediction, or to try and classify things in ways that we hope can be done at scale that humans might do if they had the chance to look at that amount of data. And then orchestration / potentially automation, the ability to act on that information. So when you produce an output of all your analytics and you say, yes, this is a problem, it doing something with minimal, if not no, human interaction. And it's difficult. It was difficult to manage rule sets. It was difficult when we were trying to correlate this with CMDBs and trying to have an understanding of risk, who is important in an organization. Have we got our joiners, movers, leavers process hooked up to our HR database, which is hooked up to our Active Directory or LDAP provider, our authentication? That was difficult. Then we started to move into correlation, moving it into getting all this external information, qualifying its validity. Is it valuable? Is it something we can utilize in our own organization? Are we at risk? And then basing algorithms on essentially all that information to try and actually go, yeah, we can just automatically deploy this firewall rule, or automatically cut that device off from our endpoint, or detect ransomware that's not utilizing any malware, just system calls that are completely generic and by design from Microsoft or Unix. You know, it's hard. So when you start to deploy solutions, software, whether homegrown or otherwise, there's a lot to take into account, which brings up this problem. It's complex. And there's no one provider, there's no one piece of software that takes all of that and goes, it's okay. Magic box, black box probably, throw all your data in there and you get profit. For those of you like South Park, or for those of you that are not quite as juvenile as I, you get business value and results that you can take to your stakeholders and say, this is why it's worth £4 million, or worth a team of 10 engineers working day and night to build rules in Hadoop, or whatever it may be. So these are the component parts, as again, how I see them. More than happy to take pointers if you've had a different experience, or if you think there's a massive oversight, talk to me later. But these are some of the key points that I see when I've either developed these type of solutions or implemented them. So the heart being the rule set, whether that is something that is built around something that learns dynamically, or whether about it's literally just if then do rules. So if CEO who has a risk rating of 1, i.e. high priority individual, and he is accessing a new device to go to a new domain, alert. That might be a rule. You might have that. Or you might have a rule that says anyone within the group of the exec operating across any unknown endpoint to any unknown domain, and so on and so forth. You get the idea. We've got context, and this is about applying, you've bought maybe a theme off a shelf, or you've bought some use cases or rules off a shelf, copied something out of Google and said, yeah, that applies to our organization. It's going, well, does it? Okay, that might be a generic rule. How do you enrich it? How do you give it insight? And that is ultimately about risk and understanding. So it's saying, who are my high priority individuals? Who are the identities within the organization? And what are the high priority assets? So that might be data, they might be networks, and so on. And that context hopefully enriches your rule set, making sure that you get far less false positives, and your true positives provide you with much more value, meaning active attacks, data exfiltration, etc. My favorite to talk about, and the one that there's most slides in here, is about frameworks, because you can have very talented engineers and consultants come in or hire that build fantastic rules, people that are really down to earth, host-based forensic analyzers who understand how to use SysMon in that perfect way to detect anything happening on your endpoint. Or maybe you've got a really rich rule set that has so many rules out the bag. Okay, it takes 5 minutes to load a dashboard, but that's irrelevant. You've got all the rules there, so you're safe. And that's great, but how do you maintain it? And without some form of framework, and this goes for many products, but Seam being the target here, it doesn't scale well. Because if you have to bring in a professional services consultant for a week to modify a rule or tune something, then you've started to become a self-fulfilling prophecy of this being the black box project that ran away with itself and provided minimal value for the financial investment. And when it comes to an organization, whether that be public, private, or otherwise, there's always going to be someone saying, so what did we get? What did we get for that investment, whether it was £50 or £1 million? Okay, so it's now in operation. We're live, yeah? Yeah, okay. Why is the project still running? Oh, you know, we've got a few things to just tie up. Okay, but you're running, that's at 1.5 million a year. And the run of it is 1.5 million a year, so you've doubled what I needed. You've doubled what I need to give. It's not a fun conversation, so frameworks are really important. Finally, integration, and this is where the extendability of the platform is important. Is it that you're going to have to create, write yourself, 100 different scripts in Python or maybe something worse to make sure that it can integrate with other products? So 21st century kind of cyber, we want things that integrate. We don't want boxes that sit on our network doing one job and there's overlap with another thing. We need something that can talk, so we need something within an API preferably. If it has an API, is it well documented? Do we have to write it ourselves? Is there a community that share API script calls, etc.? And if not, well, then you have to identify that and say, okay, so those next-gen firewalls we're putting in, we're going to have to bring in their PS to help us write all the scripts for our SIEM to talk to them, to either pull in their data or to automate blocking ports or firewall rules, or to do some behavior analysis based on the proxy information contained within whatever it might be. And so that, again, becomes a really important question to ask. Well, how does it integrate? What's the community like behind it? So I think this is the only slide with a logo on it, but this is taking the framework for Splunk's enterprise security, but from my perspective, really is just trying to highlight some of the internal components of a SIEM. This is theirs. I don't think this is that dissimilar to any other. I don't think it's that proprietary. It's ultimately saying that all those things I just talked about, they have to fit together within something. And that something is going to be software defined, and it's going to live somewhere. How does it all tie together? And in the next few slides, as we build towards the end, hopefully I'll identify what that is, and it's a collection of frameworks. So first and foremost, the bread and butter of a security operation function is notable events. That's not what they're always called, but it's what I like calling them. And that's essentially when you have something of interest, i.e. should be notable, someone should look at it, or something should look at it, where does it live? So is it an email? Does it live in an inbox? When someone picks it up? If you're a member of a team of 1, maybe 2, maybe that's appropriate, maybe that's okay. If you're in a team of 20, 100, maybe you're a global security operations center, that's not feasible anymore. Maybe you get 10,000 alerts a day. You start to see where that's going. So you've got to have a system that's capable of having an output of some form of analysis, correlation, search, whatever it is. You've got to have that live somewhere. So it's got to live somewhere, okay? And then when people touch it, it has to update and it has to change. Okay, pretty much basic database kind of terminology there. And when it changes, then what happens? Well, it goes through and it goes through your analysis phase and what are the interactions. Pretty standard, pretty simple. But again, people that simply build rule engines and go, well, we've just built our own SIEM. Oh, that's great. So where does your ticketing live? Oh, well, we just get an alert via SNMP into an inbox. Oh, okay. So how do you know who's assigned to? Well, we use Outlook labels. Done that, and it works to a point, but you get to a point where you go, this no longer works, and therefore you need to build a framework. Assets and identities, this is about context, which I mentioned earlier. This is about how do you enrich your data to understand that one IP address is more important than another. So internally, you've got devices, you've got assets, some people might call them your crown jewels. You've got things that are important and ones that are less important. A contractor's machine, which has very limited access via a secure gateway into one particular database. Okay, if the database is a dev database, not that important. If you've got an exec who's got, the latest costings for the last financial quarter, that becomes critical. That could be 10 points off your share price. That becomes critical. And so understanding that, in a point in time, okay, you can do that. You can do a massive gap analysis and an inventory and write all of that down and import it in, but it's a point in time. member of the board changes. Oh, wait, don't forget to raise a ticket to the security team. Okay, we've just had 10,000 contractors leave, and we've just had 5,000 new contractors in the last, starts to become a challenge. Again, framework, without it, you're going to be left just with tens, if not hundreds of people doing essentially basic administration, HR type stuff to keep your team up to date. So it's giving you that contextual awareness and understanding of risk. Intelligence, don't like that word, but that's what they called it, so I had to put it there. But this is pulling in all your different data sources, your threat intel, and it's saying, okay, so if we're pulling this in, where does it live? What makes one piece of intelligence better than another piece of intelligence? How does each rule or search, how does it pull in this information? Because almost every search pulls back an IP address. How do I automatically, dynamically enrich that data with what's within my threat data? Well, it's something to think about. And again, it's not that these are necessarily technical challenges. All of these things can be achieved in many different technologies, but unless you think about this from that abstraction of how do you scale it, how do you build it past that proof of concept where, yeah, we pulled it all in and in a week, look at the value, how does it scale, how does it grow? Speaking of risk, So risk is one of those things that's ultimately the driver for most of our jobs. One way or another, it's about risk appetite of an organization, whether that be a bank, a retailer, or a government. It's about saying, what is the threat? What is our vulnerability? And therefore working out what controls are in place or not in place, and that gives you your ultimate risk. So without a framework to understand that and provide that risk scoring, that risk analytics, what you're left with, again, is a reduced understanding of impact. So, for example, as we heard earlier, like WannaCry, which we all know about, well, would you want to have to go in and update all your different assets manually and say, all of these assets are vulnerable, after spending however many hours gathering that data from SCCM or whatever tooling you have, manually putting it in? Or would you want to try and build that, we're using a framework, into something that you ask that question once, and then it goes away and it enriches all that information and says, okay, here's your RAG status, these 12 assets, who are, by the way, part of your crown jewels. These are where you focus first. Here are your ambers. These are important devices, these are your sysadmins, and they're vulnerable, but they don't have access to production databases, so it's an amber, and so on and so forth. An understanding of risk is the kind of thing that CEOs, ministers, etc., want to know, and they want to know really quick. And finally, and the kind of the more recent buzzwords, other than risk, which is age old, adaptive response, orchestration, automation, all those things. It's about how do you ultimately extrapolate from, once you've done your analysis, once you have some form of understanding of what you want to achieve, doing it in a automated or semi-automated fashion. And by automated, I mean hands-off, you don't touch it, it does something. Hands-on, it asks for human interaction first. So it might say, I found all these things, I want to go and deploy all these rules, is that okay? Yep, it still at least has that stopping point, that hard stop, to make sure ultimately you're not about to cripple your infrastructure. A really good proof of concept, for example, with this type of thing, although outside of security, but I'm going to share it anyway, and it was a web server. So you've got a clustered web server farm, something goes down, it was Apache goes down, you have your analytical engine, it says this went down, it cuts a ticket into your ITSM tool, that then logs into your orchestration tool, or your configuration management tool, which goes onto the box and restarts the daemon. It's automated, it took 30 seconds, it made for a great presentation when someone pressed the button, red, 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 green, 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 ta-da. The CEO loved it, as did I, obviously. So, that's what this is about. And again, it comes back to that. Do you have to build it all from scratch? Are you about to hire 10 Python developers, bring in vendor PS, or do you have a framework that you can work with? So I think, so they're all the frameworks. This is my last slide on SIEM. These are hopefully some of the takeaways. One's not gone on to a different line anyway. So first and foremost, when doing this kind of project, so this is kind of what I do day to day, is either the analysis, the requirements gathering, the design, the implementation, or the running of seams of various shapes and sizes. And these are some of my key pain points that I've turned into how you should be successful. So first and foremost, understand what you're trying to achieve. Don't start with, I need my proxy data somewhere because I need a tick box. If you need to use that as a driver with the right people, fine. But ultimately understand what questions are you going to ask that data, what's important for you, what's going to improve the risk, de-risk your organization. So understand that. It's a really good general project management tip. Success criteria is really important. Prepare. So this is before you've got engineers on site. This is before you've got kit on the ground and you're spinning up all your boxes. Prepare. The amount of times you come to go, right, you've got this brand new shiny, right, so give me some key identities. Oh, I didn't know you needed that. Okay, let's start with the board. Oh, it's going to take me a week. I can find it now online. It's going to take me a week. Okay, well, let's start slow. I'm leaving tomorrow, but we'll get there. So, prepare. Really understand what are the requirements outside of technology, because technology is one thing, right? You've got people and process. And if you don't have the people trained and equipped with the right access in a timely way, it's irrelevant. If they don't have an understanding of what's the expectation on them, what they're meant to do, what they're meant to use it for, so I'm talking about that fun documents and procedures based on processes which are repeatable and refined. Again, you fall into that. It's just a box in the corner. Or sometimes it makes noises and we get a few emails and then we leave it alone. Integration, the more you integrate it, and I mean really well integrate it, not just, it's integrated with our Active Directory, what's it do? I don't know, but it's integrated, tick. The more integration, the more business value you're probably able to get from it. So you start with security, you might bring in more business value, such as Keith said earlier, like digital. You might be able to help with transformation by saying, so we're capturing all of our authentication logs on our web server for security purposes. By the way, would you like to know which customers and at what point leave things in their basket? Oh, well, we've got a really expensive business analytics tool for that. Oh, well, I just did it in the same tool set. Oh, cool. And finally, embedding. So this is about change, and that phenomenal word transformation is this should be part of something. This in itself actually isn't going to change that thing. This isn't the thing that you go in and go, right, wow, we've gone from maturity of 1 to 10 overnight. It was incredible. It's got to be part of something bigger than itself, because there's so many other things that are the inputs, the processes, or the outputs of this that it will depend upon. And that's about culture, that's about other technologies, it's about training, awareness, and so on. So that's all I've got on Seam. Little plug, I run the Splunk user group. We meet at Napier. Please come along if you are inclined, if you like it. And that's me. Any questions? Yes? You said manning. Yeah. So the question was, so this is predominantly around building and delivering a Seam solution, and this is more around running one, an operation of one. So I think one is, if you've been enabled from the project, from whoever's delivered it to you, who's given you some of the tools and the frameworks, that should help. If not, which is often the case, I would say try and abstract yourself a little higher and say, well, what does this exist to do? And then try and build some of them yourself. So if you don't, for example, have an understanding of when you take, let's say, the output of a risk assessment, some threat modeling, and you have a new use case, try and build that. Try and go, okay, I've been reading online about this new threat, WannaCry, it sounds really bad, are we exposed? Yeah, you can go straight away and start running some searches and trying to build some rules, but what might be better is to try and formulate that hypothesis a little bit more, and then we get into a little bit more threat hunting and say, okay, we don't currently have rules that match that type of behavior or that type of activity. How can I build that? Well, if I build a search like this, get it peer reviewed, get some insight from some colleagues, and this doesn't have to be a massively long document or anything. This can be a nice, agile, iterative process. But they say, right, I've got this hypothesis, and I just asked all my endpoints this question, and they're telling me this. Looks like it's right. And then you say, right, this should become a rule. This should become a new thing, implementation. And so try and think bigger than just the kind of the search and respond, and try and think, well, how do I build this into something permanent? And there's lots of really open frameworks out there. Some of the threat hunting frameworks are fantastic, which are really about building that hypothesis, how you refine it, how you implement it, and how it becomes a permanent staple of your scene. Any other questions? Yes.
Just wondering what you made of the AI dark trace minority report type stuff. The AI engines are trying to predict things before they actually occur.
So I'm not sure what I personally think of the term AI when in use with most technologies, but tools like those, so as they might put it, next generational endpoint monitoring and other types of monitoring, I think there's a lot of value there. I think last meetup, in fact, we had a really good chat about some of the ways that endpoint, like malware analytics, or that what isn't malware but is malware analytics, the kind of the next step for that, about kind of tagging behavior of processes, not signature driven, not really heuristic driven. I think that is fantastic, but you've got to still have a way of collecting that information and hopefully correlating it with your other layers of your defense. Any other questions? Yes.
You had a really good couple of examples there of value out of the solution. I see them that doesn't directly relate to security. How often do you actually find that customers take that and run with it? I mean, I personally have seen this for a while, and actually a piece of work I did, and I actually identified a few ways, like supplier management, being able to actually test SLAs and things like that is certainly value you can get out of a SIEM. How often have you seen it? Because I've done the odd piece, but it's not my bread and butter.
Sure. So the question was, especially for those tuning in, was what other business values driven out of this type of security-based deployment of a SIEM? Is that right? Yeah. So from my perspective, it's easier when your initial use case is not security-based, because security people tend to like to hold on to their toys. So you give them a lovely big data analytics platform and you place a SIM on top, or you build some rules and they go, that's amazing, that's great, let's bring in all this really great sensitive information. And then you go, oh, and actually there's this business unit that would love to, no. Oh, no, they're just, no. Sit down. No, but it should, sit down. So, it's often, again, about kind of leadership at that point. So if you've got the right business drivers where it's part of a larger strategy, you can have that conversation easier. I've seen it work really well in a couple of cases. So one, I mean, it's security related, but that was a great fraud one where a large retailer had initially gone for that big SIEM deployment, and they were kind of, on that journey there. They were just finished, I think, delivering it, and their fraud department said, it's coming up to the holidays, we get a lot of fraud via our e-commerce. Can it help? And we were like, well, yeah, I mean, what do you currently do? And they said, well, we currently look for these 32 things. And so we worked with them over a couple of weeks to put that into essentially pseudocode and said, this is what we look for, and it looks like this. And when it looks like this, we want to do this. And then we wrote that into the big data platform, and we built a number of dashboards, which gave them that lovely RAG status for it and a bit of automation. And it was great. And, it was really fun to work on as well, because you were kind of, oh, that's an interesting question, I'm not sure. Put on a different hat, what's motivating you? Excellent, take that forward. So easier conversation when security is not the original use case. If you've got the right audience and the right people are helping you with that question, i.e. often not necessarily working with the people on the cold face, a bit more high stakeholder buy-in, conversation typically happens faster, as with many things. Any more questions? Have we run out of time?
I've got a mic here. I keep forgetting I've got it.
This thing on? You spoke a little bit about AI in regards to dark trace, etc. But can you talk a little bit about UBA?
Okay.
Have you found it useful?
Sure. So the question was to talk a little bit about my experience and/or opinion of UBA. So that being kind of user/entity behavioral systems, I assume, and analytics. Hands-on is limited in the sense that I've done far more SIEM type work than I have UBA. I think UBA is fantastic as a technology, but I don't think it is the death of seams that it may have been made out to be originally. I think it does some phenomenal work in some very particular situations. I think it's great for insider threat. And I think that you'll struggle to get similar value in a lot of seams that you can get via a UBA type tool for insider threat. So there's some fantastic vendors out there that are cutting edge and really pushing it forward. I think it's a very new thing as well, so you've got to really qualify the value it's going to bring versus the spend, like with all things that you invest in. I think that if you utilize it and have it feeding into and fed from a seam, that you're going to ultimately get a much broader coverage of kind of, security controls, use cases, threats, etc.
Actually, just a sub-question. If you were to, talk about Splunk in particular, if you were to use Splunk and then have your own machine learning and develop that within that, are there protections in place to keep that your information, your ranking?
So the question was specifically around Splunk. If you are developing external to Splunk or on Splunk?
As a plugin.
Okay, so if you were to develop your own code using machine learning algorithms based on the Splunk platform, are the ways to protect your own intellectual property. So, and this is by no means an official statement, but from my perspective, if you're implementing either your own algorithm or you're leveraging one that's open source or correctly licensed, whatever you build from a kind of source code perspective is ultimately still your IP. Sorry?
There's no requirement to share that.
Not that I've encountered. Ultimately, Splunk as a company have an online community and app store where you can host things. But even within my company, we've developed several apps or plugins, as you might call them, that are not publicly hosted or available. There are IP. They leverage Splunk's technology because that's what we like. We find it fun, but they don't own it. So I would say your IP is safe, but you may choose to share it if you wanted, like anything else. No problem. Okay. If anyone does have any more questions or challenges, which are also fun, you can catch me later for a drink.
Cool. Thank you very much. Please follow Harry on Twitter because he's very good. We have Stuart Peck from 0 Day Lab, who's going to talk a lot about WannaCry, which is one of our
not Petya,
and Petya as well, yeah. The variant.
Or the not ransomware attacks. Everyone hear me okay? Excellent, there you go. There I am. Hello everyone. Hello the internet. I'm Stuart Peck. I head up cybersecurity strategy for 0 Day Lab. I'm also part of the incident response team. So I was respond to a lot of cyber attacks. Generally ransomware is my specialist subject. If I was in a mastermind kind of thing. So there I am. I've been in cybersecurity for about 13 years. I have an interesting journey, not a usual journey, from pottery to cybersecurity. It's the best journey in the world. It's not the usual career path that most people are going to, but I highly recommend it. So I'm going to talk about a real world case study of a very large international company who I can't mention because obviously they're still going through an incident, but I can talk about what happened and how we responded. This happened very, very quickly. It's in response to NotPetya. The client was very large, operated over 120 countries, or 160 countries in this case. They had over 20,000 devices, very, very large. As of 27th of June, they were infected with malware. Or they just signed up to our incident response service, actually. So we had literally 2 weeks ago, before it happened, we had this phone call. Literally, they'd signed, the ink wasn't even dry. Had a phone call. And they got a phone call. I was actually in New York at the time, which is quite convenient for incident response. So if anyone actually done like an incident response scenario workshop? On here, show of hands. Yeah, I'm the person that's always on holiday on the phone. Every time I go away anywhere, a cyber attack happens. It did with WannaCry. It did with New York. I was in New York, actually on work. And literally, we deployed our people very, very quickly. We thought it was isolated until I asked for the client to send me a screenshot of his of the ransom message. And he said, I can't send you a screenshot. And he's like, well, why can't you send me a screenshot? He said, because I can't access my computer. I said, OK. And anyone else experiencing this? Yeah, half the country, half the world. So it was spreading really, really quickly. So we had to respond to this really, really fast. Now, what we found was that at the time of creating our war room, there was no media on this. So we were very, very quick to look at what was going on. We had to make a judgment call. Now I knew this was actually a version of Petya because I spent a lot of time researching malware in my evenings. I have a very interesting job. And I spent a lot of time researching malware. So I was aware of the process, the tactics of Petya in terms of encrypting the master boot file records and the master boot records. The difference was this was spreading really quickly, so we knew someone had weaponized this. So we knew this was quite bad. So I reached out to some people on Twitter, so DM I did, and I just said, look, is this bad? You know, have you seen it anywhere else? There was still no media. And a few hours later, Michael, who was very, very good, you should definitely follow him. He's part of the Malware Hunter team. He's actually created ID ransomware as well. We realised it was quite bad, and it was really, really bad. So what actually happened? What was the root cause? Why was it so bad? This is actually a screenshot of what we saw at the time. It was pretty bad. And why was it so bad? It's because it was through a third party, right? So most ransomware attacks, you can find a signature. Right? There is some evidence to find at the time. With this came through a third party piece of software, which is most likely, and I say most likely, MEDocs, it hasn't been proven that it fully is yet, but it's most likely to be. So the cyber threat actor had compromised the third-party service for potentially quite a long time, had used a malicious update to deploy the attack. So this attack actually had a trusted signature. It came from a trusted developer. That trusted developer was in most companies within Ukraine, which is the source of the attack. So you've got all your controls in place, and you've got an attack that's coming in with a trusted developer signature. So if you're running application whitelisting, you've probably whitelisted this already. Okay, so you can't detect it at that point. It's also using Microsoft controls. It's using WMIC. It was also using PS exec as well. And it was literally using Mimikatz to find passwords stored in memory and using WMIC to find out where it could connect to. So what can I connect to? Apparently the whole network. And it could spread really quickly using PS exec. And within an hour, it would then force reboot the machine. Okay, so what you would have is the advice usually is in most ransomware attacks, disconnect your machine from the network and then wait for someone to turn up. But what the threat actor thought about this said, well, most people will disconnect the machine from the network. So what we'll do is we'll schedule a task after an hour to force reboot. So our ransomware will take control of the master boot file records. It's really, really clever. This happened, infects the update infects the business, and then very, very quickly, everyone gets attacked. Right? The whole spreads across the network. Basically resulting in this, okay, which is basically what happened, right? So, so all these companies being affected with ransomware attacks and across the whole country. We all know the story here. Even armed police turning up to confiscate the services and all that kind of stuff. Really, really good. Really bad. So before, if you think about WannaCry, this was WannaCry, right? What happens is you turn up, you patch, right? You didn't patch, you get affected. Unfortunately, with not Petya, you patched and you were affected, right? So that was the problem. It's the same thing, right? So these are the things. The challenges are the advice changes. And when we do incident response work, this is the problem. We give different advice. We have to have a plan. It has to work, right? Now, I can't talk about the companies that I've dealt with on this on a global basis, and I'll give you some experience of how we responded. But I can tell you this has massive impact that we haven't seen before. And WannaCry was bad, right? Because it spread globally, okay? It had massive impact. But this has incredible impact on businesses that were affected. Not as widespread, but the damage was done. This is WannaCry done by pros. This wasn't ransomware, though, of course, and I'll talk about it in a bit. This was never meant to be ransomware. This was all about political destruction of data, okay? This was so bad. The PR on this was so bad that the creators of Petya, the original creators of Petya, Janusek, right, had gone, I'm distancing myself from this. This is not us. This is not us. We'll release our private keys So anyone that's been affected by this can actually, can get their money back, or they can decrypt their data, okay? Of course, their key didn't actually work with this because it was completely different. It was never meant to be decrypted, okay? So, how do you respond to cyber attacks? Well, our advice in this case is forget the how, why, and when, and just contain. Right? The most important thing you've got to do at this stage, when you're being faced with an attack that's spreading across your network really, really fast, is about containment. And when I talk about containment, I'm talking about really, really fast containment. So what we did is we disconnected all those servers. We told the businesses to disconnect their servers, their desktops, their networks. 120 different countries, 20 different data centers, disconnect the lot. Basically, the years you've been spending building your data center, got to do with reverse engineer it, basically break it, okay, to protect yourself. Kind of weird concept. You have to create a comms plan internally. Now, the problem is, how do you create a comms plan when you have no email? Okay, it's quite difficult. Carrier pigeons, that's quite a good one I found at the time. How do you prepare your external comms when you have no email? Okay, again, so there's a whole kind of challenges we don't even think about. We don't plan for these scenarios. Okay, it's very, very difficult. So we decided to create work streams. So what came to the conclusion was we use WhatsApp. WhatsApp is absolutely brilliant for this type of scenario. WhatsApp is fantastic. Everyone has an out-of-bounds communications plan, right? So everyone has maybe their own kind of system that's out of bounds, but that's taken off by a cyber attack. You would have left with nothing. Everyone has a mobile phone. They can use it for this purpose, okay? And then, of course, we've got to focus on a couple of things. First, containing the spread, because that's important. Second, we've got to find out who patient zero is. Where are they? Where was it found? Okay? What was the source? At the time, we had no information at all. And most important, we've got to get back to business. Okay? Really, really important. Okay? So, we did that, but this is what happened. Okay? What was affected? Pretty much email, any communications, virtual services, physical services, anything Windows, gone. Right? Literally within an hour and a half, this happening. Critical applications, the ability to patch. Okay, these guys had a SOC, Security Operations Center, and the SOC analyst couldn't access the SOC. Had a brilliant scene, by the way, brilliant, well configured, but because the machines they were using to access the SOC were down, they didn't have a plan for that as well. Okay, so these are things we don't even think about. Okay, and of course security applications. So if you can't patch and you can't actually protect yourself, you're exposed to further cyber attacks. That's what we want to help them prevent as well. Okay, so. Obviously, there's the bit, how would you do it? Well, we talk about protecting, if that didn't work. Discovering, yes, we discovered it. We need to react, respond, contain, eradicate, remediate, okay? And most times we have a plan for this. The service desk or the business might investigate it, they'll confirm the incident, they'll form their CSERT, and then what? Well, it's ransomware. Okay, so in this case, it's not a priority 2, it's definitely priority 1, because we can't access anything. And this is how we go into it. We kind of think about how do we go and do this. So the most people go, well, let's find out what's happening, what it is, how it's happening. We need to run the different work streams at the same time. One is understand what happened, how we were attacked, what was the indicator of compromise, what was the source of entry, and then we've got to contain the threat because it's really bad. Okay, and this is kind of what I think about when I talk about planning for the worst, right? So you're trying to contain the threat and you try and plan for the unexpected event. But no one plans for a shark flying into your house, right? And this is basically what NotPetya was. No one thought this was even possible, okay? So what can't you prepare for? So everyone prepares for an event, and an average, and I do this all the time. I talk about customers. What's your kind of longest security event? Most people go, about 3 days. That was really bad, okay? What about something that lasts for more than 3 weeks? What about TNT? This is going to last until Christmas. Or Maersk, who have pushed out plans for really important medicines, okay, because they can't get their systems back online. This is having real impact to business. Okay, no email for 2 weeks. Think about team motivation. You've got a team of people trying to organise over 120 countries, disparate IT teams, keeping the information flowing just via WhatsApp to start with. It's challenging, right? Because you have the rumour mills. Okay, everyone's saying every time you're in this cyber attack, the smallest news story, everyone goes, oh my God, we're under attack. Okay, this is it, it's over. We're under attack again. No, it's just internal communications. We've actually managed to find a way to get emails out. And this is what's happened. So we've got to be very careful about protecting those kind of things. Okay. Third parties, they're absolutely vital, but if you're heavily reliant on you've outsourced your IT, then your incident response plan is completely different. Okay, you're relying on their incident response plan, not yours. Okay, and I can't stress it enough. Fatigue. the lack of sleep me and my team got for the first week. I was in New York as well, so I was on every time zone for that week. It was amazing. But literally no sleep for weeks. You just kind of think about it. It's crazy, okay? So when you're preparing for these things, you need to think about all those scenarios. Okay, so when you're trying to talk about how do you prepare for this, well, you talk about what assets you're trying to defend. Okay, well, actually, all your assets are gone, so it doesn't really matter at that point, right? Do you have visibility critical assets? No, I don't, actually, currently. Can you detect unauthorized activity? Yes, it's on my screen right now, okay? Can you classify the results? No, but I think they're pretty bad. And then you can see the indicators of compromise. We're pretty compromised. You're getting the story here, right? So this threat hunting kind of detection is kind of quite bad. But can you deploy countermeasures to fix and recover? Well, this is the problem. But when you get to here and you've really that badly compromised, that's what happens, okay? And we see this quite a lot. So what we try and talk about is building a maturity. Having these tools and these, we want to prevent as much as we can. We want to detect as quickly as possible so we can react and respond, okay? But when we've got no ability to detect because it's coming through the back door with trusted developer signatures, it's a big challenge, okay? So I talk about the kind of attribution and who's behind it and how do you attribute. Most people go, hash value is very important. Open source intelligence is vitally important. The community is fantastic, okay? There's really great tools out there, okay? So, but there was no command and control server for this. So there's no IP addresses to look at. This is really relying on email, which you knew at this point. You create something so sophisticated and you want to communicate via email, that's probably not the reason you want to get your money back, okay? No host artifacts, because this was wiping forensically the data as it was going through. So we did 3 or 4 forensic analysis on literally the key ME-doc server and all the other devices that were infected initially, nothing. We got a couple of services that are running. That was about it. It was wiping as it was going, okay? It was hiding its maximum destruction. And then, of course, we knew what tools they were using. We knew they were using Mimikatz, WIC, PSExec. This was definitely political, not financially motivated, okay? So this is what I like to think about when you do forensic investigations. This is what NotPetya did to the forensic evidence. Just basically went, this, thank you very much, okay? So, yeah. And then we talked about attribution. So if in doubt, it's either these ones, really, pretty much, okay? Okay, so, yeah. So when we talk about how bad it actually is, okay, how do you move from response to recovery? Okay, well, there's a couple of things, right? So one is that we need to connect those devices back, okay? We need to connect those data centers back. That was a really big task. And one of the biggest tasks we found was there was no central networking. So you think about patching, right? How important patching is. And you have no antivirus for about, what, a week and a half? So you've got to think about how you push out the critical patches that now you can detect this so you can't get reinfected, okay? So we had no way to push out by SSCM. We needed to re-image and rebuild AD, which was apparently was quite a fun job, I was told. It wasn't my team, so that's good. No email, but we're able to literally fast track them to Office 365. Literally, they were planning to do this for a year. We did it in 5 days. The quickest migration you've ever seen to the cloud. Okay, adoption, amazing, right? And then, of course, providing machines, all this kind of stuff, right? So there's lots to do. But right, what was really interesting about this is that when you start looking at containment actions, right, they're the same process. Okay, you still need to build. So there was a massive investment. I think the share price in USB sticks that week went up tenfold because they bought so many of them, because you have no way to potentially push out the patches. Re-image machines. Think about, let's say, 10,000 machines. You've got to manually re-image because you have no way. That's an IT administration nightmare right there, let alone the loss of operational time. Okay, so it's a really, really big task. Okay. Eradicating, okay, so we've actually going to be containing it, we've contained it, we've managed to patch our systems, and as we're creating a clean build, we've eradicated the threat from our network, we're then manually rebuilding and re-establishing those machines to the network one by one. Because you can't afford to have one machine, which we had, one machine, a Windows 10 machine, that somehow didn't reboot, and every time you tried to connect to the network, it was trying to reinfect machines. Okay, so that was just a fault, but everyone then thought, well, that's it, it's obviously sleeper malware, okay? Of course, it wasn't. It was just a fault. But the point is, you have to kind of prepare for these things. We have to create a new strategy of clean build, prevention, reinfection. Okay. So really, I want to talk about the one thing about this. Right. The last thing is about comms. Okay. So you rebuild your network, and how do you then communicate with your customers at the same time? Well, basically, what I say is actually control the story don't be the story, okay? Actually going out early, explaining what you've done and constantly communicating with your clients, your stakeholders, what you're actually doing is the best thing, okay? And it takes a while to build these programs, okay? And it takes a while to actually get the message out there. But once you start getting out communicating with your customers that you're actually working to restore to services, the actual sharing the business plan, you're in control of the story, you're taking the mic and you're throwing it down basically, and that's how you kind of work on it. And that's really it. I've kind of covered quite a lot, hoping to get more sort of questions as well. So any questions? Yes?
I think it was normal users having local admin workstations.
It was any password at all. So local admins, yes, was a big problem. So having local admins, yes, was a big problem. I think there's also the shared admin credentials, and quite a flat network was also a big problem as well. This was deploying two mechanisms. So if you didn't patch for your SMB services, you didn't do the WannaCry sort of patching, then of course it would deploy that, and you would bypass those sort of issues as well. But because it was harvesting any sort of plain text passwords that were stored in memory through Mimikatz, then it didn't really matter what access. But if you had local admin, yes, that made it worse. Yeah, there was ways of bypassing that as well. So there was, but local, because they had actually removed local admin from the machines. So they were actually bypassing the need to run local admin in certain circumstances. But typically, yeah, local admin was the problem. They actually landed on a machine that had the administrator account. Right, that was very lucky, because actually if it's coming in through an ME docs, supposedly if it was ME docs, let's just say, then once it landed onto that environment, the server had administrator accounts, generally speaking, because you'd need administrator accounts to run the software, so it's harvesting those. And then, of course, they would use that to attack other administrators, and then it would spread. So if you've got a fairly flat network, then it would spread quite quickly, as it did. If you do have local admin accounts enabled, then again, that's a big problem for any kind of malware. Right? It isn't necessarily this. So, for example, there's a big threat coming up with the TrickBot group, who are building up Emotet, and they're doing that using the same techniques as WannaCry and NotPetya, and they're trying to build a self-replicating Trojan, banking Trojan. So we're seeing this whole trend emerge at the moment from these kind of attacks. So this is, yeah. So having local admin and enabled is bad. Actually, one of the things we recommend is if you're using like password manager tools, or and I'm not mentioning any brand names, but there are quite a few out there, or you're using some of the admin, the privileged account or identity management tools, that would stop this in its tracks. Because literally you'd just literally be able to rotate the passwords across your network, a couple of minutes, it would kill it. So there are quite a few ways of preventing it. Any other questions? Yes? As the result of this, not yet. Yeah, so I think there's a whole range of, I guess to answer your question, we've not seen a huge move away from Windows yet. I think because there's an operating system, there are some benefits. If you look at Windows 10s, that they've proved that would theoretically stop or reduce the risk on this. I think there's a lot of work that needs to be done throughout the whole industry to improve. I definitely think kind of migrating away from the older operating systems is always a challenge, especially when legacy technology still needs it, and there's also the business decision of actually trying to move away. I think leveraging cloud is always quite important. So relying purely everything just on-prem is a risk, because if your infrastructure's taken offline, you have no resilience elsewhere, and that's what happened here. So having an ability to leverage both the cloud and on-prem for certain services does give you the ability to flex.
Well, that's until your cloud provider gets hit and they get taken down.
Oh yeah, there's always that, right? And yeah, of course, it's a perfect storm. There's always a perfect storm, right? So but you have to have something in place, like your failover. So if your failover, so their DR site was hit, so your backup plan, you think, well, we just fail over to the same, right? So it's kind of, you have to kind of think about, this is a unique scenario. I don't think we're going to see this again, hopefully until like next month maybe. But it's always about a month, isn't it? So, but this is a newer trend. So businesses are having to adapt quicker to these real perfect storms, like Cybergeddon as they call it. I don't really call it that, but you know, but it is quite bad. And we're entering into a new world where we were working towards having almost the upper hand. I wouldn't say we do, but we're working towards getting a handle on cyber attacks to some degree. And then these curveballs come in, and we're thinking about our plans again. Yeah. So again, it's all about thinking outside the box. The whole point of talking about this was to get you to think that whatever you think is in your business continuity plan or your cyber incident response plan, have a perfect storm that you can not possibly conceive, okay, and plan for that, because that's the one that, if it happens, at least you plan for it and stress test it, okay? Stress testing for a day is quite bad. Yes, sorry.
So you talk about having a plan.
Yeah.
You talk about step one is containment, cut things off. So what are the preparatory steps you can take at a practical level to be ahead of this?
So you have to repeat, I couldn't hear you the back end there, sorry.
Yeah, what are the preparatory steps that you can get out ahead of in terms of technical items? So that once you've contained,
Yep.
you can then go to discovery phase.
Okay, that's a very good question. Okay, so what are the kind of the forensic things you can do? What are the kind of containment actions you could the technical containment actions? There are quite a few, not from a technology point of view, but there are some good technology that you can contain quite quickly. So I've worked with companies where they have their SOC is they have a SOC, and their SOC is able to remotely contain stuff, and there are certain organisations in this room that do that as well. But there is a way to the SOC can contain something quite quickly. Okay, the key thing is identifying, depending on your environment, of course, identifying what your kind of key assets are. And where the critical assets are, and start with the critical assets, the most operational assets first, okay? Because ultimately you can cut your arm off a little bit, and you can still live another day. Cutting your head off is slightly more difficult, right? So you need to start with stuff that you really absolutely need to contain. In terms of technical options, it depends on the scenario, because there's so many different scenarios, right? And so from a containment point of view, it is really the step I usually take is get that system off the network first as quickly as possible. Now, you can't always do that easily, because telling a user to take a computer off the network generally means where's the network cable, what does that mean, and then you have confusion. So actually being able to have a plan, some people say just switch computers off. Having a communication plan immediately to people as quickly as possible to do that is really important. Having the ability to remotely do that is even better. But again, it just completely varies. Every organisation has a different setup and different way of doing it. There isn't like a silver bullet, I guess, is the question. Does that answer your question? Okay.
The question was more about what you do before containment.
Oh, okay. So prevention. Talk about prevention. It's ish.
So you cut yourself off.
Yep.
Then you say you move to fix. How do you put the steps in motion so that you're in a position to fix when you've already cut yourself off?
Okay.
What do you do in peacetime to prepare for it?
Yeah, okay. So it's about actually you almost have to run those things simultaneously. So you can't do one before the other. You have to kind of, have a team working on containment, kind of triaging and containment, and a team working on what's actually going on. If that makes sense. You have to have the technical ability to be able, the technical tools to be able to discover what's going on, so you can then feed that into containment. Because ultimately, if you think about this particular scenario here, no one really knew where this was coming from. Okay, no one knew really how it was spreading. There was nothing to go on. Okay, all we knew is that machines were switching off and rebooting. Okay, and there was no ability, because I was off site and my team were off site, and the security people were on site, but their machines were gone, bricked, right? So they had to go on the local teams, but the local teams, because they spread so quickly, the advice was get the machines off the network, okay, and then try and get a machine to a forensic analyst to try and investigate it. Because at that point it's too late. Before that, preventative actions are actually training your people on first responder and doing these simulations to actually work out how you would actually contain it, and having a list of tools that you can kind of get to a point where you can literally contain something from immediately. And there's lots of open source tools you can use and lots of commercial tools, and I want to go through a tool discussion today. But there are a whole range of tool sets which I can probably share with you if you want, on what you could do, and a kind of plan you can put in place to kind of get to not prevention actions, but technical actions that if this has started to happen, you can contain the threat. That good? Yeah. Okay, fine. There's a lot. I could talk about this all day, and I probably are loud. Is there any other questions? Yes.
Just one at the start you mentioned about NotNet shipping, not ransomware.
Yes.
Would you be able to shed any light on what the actual motivation was? Because like I gather it was sort of like take out like critical infrastructure. And that sort of
Yeah, I can go into what we think it is. I think the challenge with this is there's lots of theories, right? And one of the theories is that if you think about the target was having a chat to a CISO about this morning. Okay, so what we were talking about and my kind of theory behind it is there's one of two theories, right? One is this definitely was state sponsored. This definitely the motivation was to damage infrastructure, but I don't think the attackers realised that this would spread really far. So if you think of this analogy of and I'll use my colleague's phrase. They wanted to use a chemical attack, which means that they could come in afterwards and clean up without having to wear masks. They used a biological attack, and it spread outside their control, and it even affected the targets that they weren't expecting. Okay, so this is the kind of thing we can't really talk about too openly. But so if it was and most likely a state-sponsored attack, the impact was far greater than expected because you wouldn't want to damage every country because then you make yourself a target for counterattacks. So there is a degree that this has to be maybe state-sponsored or very least a cyber attacker that was trying to cover tracks. Okay, so but given the primary target, the date it happened, okay, and where it came from, and the tactics that have been used in other wiper type attacks. So the group that might be behind this has been involved in lots of wiper attacks before, and the same tactics are being used in terms of using third parties to deliver it. It's very likely to be a sponsored group. Does that answer your question? Yeah. Have I got time for any more questions? Or yes.
Vulnerability-wise, right? Most of these things are exploit vulnerabilities.
Yep.
So actually, if you're patched as soon as they came out, how would you actually have a business, if you see what I mean?
Yeah. So you're asking basically, is patching a viable defense mechanism? Yes, of course it is. But also, so is segregating your network, and so is having strong passwords and all the stuff we talk about every day. Good kind of operational security. In this particular scenario, is actually your third parties, actually understanding who you're doing business with. So the biggest threats that we see are coming through third parties now, right? So you outsource all your data, and that provider gets hacked. You've given all your controls to that company, and therefore the risk of their controls that may not be as mature as yours, right? So software development security, for example, we have some amazing coders out there, but they're not the most amazing security people, okay? And I think there was an article this morning where coders were being attacked through browser extensions within Chrome that were being exploited by hackers, right? So there's always going to be an angle for an attacker to go into. They'll always go for the easiest and the least difficult and the greatest scale. So to answer your question, if you had patched, you'd still be affected because it wasn't necessarily vulnerabilities being exploited. It was using, Windows tools to deliver the attack. There were some obviously stuff going on as well.
It is very much a hybrid approach for defence.
Yeah, you have to. You have to have defence and depth, and most people say education, but these two large attacks weren't anything to do with phishing or anything to do with people clicking on links, okay? So, you still have to educate your people on how to respond to these attacks, but you have to, the threat landscape is changing slightly. And I think these are going to be very unique cases, because the most common attack vector is coming in using the exploit, using some kind of phishing attack or some kind of drive-by. Today. This business model, I think, is going to be where people will move towards. But there's a lot of development time gone into this and a skill. And, of course, everyone has to blame the shadow brokers or the NSA because, of course, they have helped these attacks along. But this would have happened anyway. They would have found a way. It's just we kind of made it easy for them. I think I have time for one more question, I think.
Yeah, go for it.
Yeah? Any more? Or not. There you go. There you go. It's brilliant, right? There you go. It's all done. Well, look, thank you very much, guys. Thank you.
Brilliant. So thank you to the people watching online and who are watching this back on YouTube. So if we can call it a day there, that's cool. There's a reason why I'm calling it a day online. So.